listening at home, howdy. We're going over worksheet 5J-2. Please take that out. Pull up the answer key. Have it coming around in forward. Okay, let me see what you have. Good?
Sorry, I have mine.
It's not going to work anyway.
It's an Apple Pencil.
It is. It costs like $100. It works beautifully on that thing.
Some of them work for number one.
Ah, okay. I bought it during the COVID exile. Oh, I see.
Max, I can probably convince me here.
Oh, wait, no. Stop. It's not funny, it's just inappropriate. I expect higher behavior from a person like you. Also, I am straight action. Yeah.
Yeah, but you're supposed to get the, oh yeah. Upper and lower sums, isn't that fair?
I didn't finish it because I was at work, and I'm sorry. I'll have it by the end of today.
Don't throw academic breaks at people. All right. Let me call this over here so people at home can actually see a human being on the screen. Each of these are going to take a little bit of time because the computer doesn't generate these, but have your worksheet out? Gentlemen, red writing utensil. Let me see. -4 to 6. And first of all, number one, I'll give you the number of slices you need, the number of paren, and then I'll give you the various answers. If n is equal to 10, the upper sum should be 55. Oh, wait a minute, what the heck? I'm running the wrong program. Never mind, hang on a second. Let me start that over. There's a story behind this. I wrote this a few years ago to now. So from -4 to 6, 10 slices. That's better. Upper sum is 65. Not bad. Lower sum is 55. Trapezoid sum is 60. Midpoint sum is 60. Simpson's rule is 60. And the exact answer is 60. And it repeats on that one. Next, let me type this in real fast. So negative x squared over 2 plus 6. There should be 5 slices. Upper sum is 27. Lower sum is 20.5, or 41/2. Trapezoid sum is 23.75. Anybody have a fraction for that? Yeah.
I had 47.5/2.
Oh, I suppose 47. If you get a, I'll accept that. Technically, decimals inside fractions are considered uncouth. So if you multiply top and bottom by 2, that'll get that'll reduce it.
That's why my calculator kept putting it over 4.
Yeah.
Okay.
So everybody get trapezoid sum? Midpoint sum. And this thing isn't giving me fractions, but I suppose I could. It was, 46.
Is it 95 or short?
Yes, 9/4, thank you. Midpoint sum, which is even more gross. It's basically 24 3/8. 24.375. It's 24 times 8. I don't know. I'll have to add a feature to put this into fraction form. The Simpson's rule is 24 1/6. And the exact is 24 1/6. Does that mean we need those in fractions? I can change the program in like 10 seconds. Well, 30 seconds. I'm not quite that fast. Blah, 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 blah. Yeah, sorry. This inside the program, it doesn't really do it. If anybody wants a fraction, let me know. I'll convert it for you. Go to number 3. By the way, if you notice, if something is a parabola, gentlemen, if something's a parabola, Simpson's rule is going to give you an exact answer, pretty much always. So new formula for number 3, it's enter y1, so x squared over 2 plus x plus 1. From -2 to 3, there should be 5 slices. Upper sum is 18. Lower sum is 9.5. I hope I typed this incorrectly. This is not looking right. Hold on. I think I typed something wrong. Hang on. Wait, hang on a second. X squared over 2 plus x plus 1. Yeah, that's right. Okay, let me run that again, sorry. That was looking a little weird. From -2 to 3, 5 slices. It says the upper sum is 18, lower sum is 9.5. Is that matching anybody's answers? These are looking wrong.
I had 17 and 8.5, but maybe I messed up. So.
That sounds right, actually. What's up with this thing? Hang on a second, sorry for the delay. People listening at home, I'm sure this is really exciting. Go get a bowl of chicken soup or something. I'll be right with you. Okay. Let me run this one more time. So enter new Riemann sum. X squared over 2 plus x plus 1 from -2 to 3. Yeah, 5 slices. This is still giving me an upper sum of 18. Just a second. So it should be 6 plus, no, I take that back. It should be 9 plus 5 plus, whatever that is, 2.5 plus 1. Let me just add this up by hand. Tell you what, I'll just do that on the board if you don't mind me skipping it. Let me try another one. Quit. New formula. Gentlemen, please don't chit chat, I need to be able to hear. X squared over 2 minus x plus 2. Please God, this works. Should be from -1 to 4, there should be 5 slices. It says an upper sum of 17, lower sum of 10.5, trapezoid sum of 13.75. This is not looking right either. No, something's terribly wrong here. I'll just do them by hand. Did we do number 5 by hand? Or number 5 on the board yesterday? I'm just going to do number 3, 4, and 5 on the board. I'll see if I can do them fast. Number 3. Sorry about that, that was awkward. Y equals x squared over 2 plus x plus 1 on the interval from -2 to 3. refresh my memory as long as I have your attention. How do you graph that? It's a pre-calc problem.
Can, isn't it like 1/2 x squared basically? So then you.
Correct.
That's your height multiplier.
Okay. Now what? How do you find the vertex? It's been a while. You need to do that. I mean, relying on the calculator is one thing, but you need to know how to do this by hand. Anybody remember complete the square?
Yeah. You could also just plug in values of x and get their y and then figure it out too.
You can, but none of those would necessarily be the vertex. The vertex might not be a whole number. In this case it is, but and oftentimes it isn't. Question?
Can you do like negative b over 2a?
Yes. The vertex is the axis of symmetry, which is negative b over 2a, comma, and then the plug-in value. See what it is. So in this case, negative 1 over 2 times 1/2, which is negative 1, comma, plug in negative 1, negative 1 squared. Anyway. Yeah.
Thank you.
Negative 1 squared. 1 times 1/2. 1/2. Did I pick on somebody specifically? So 1/2 plus negative 1. Negative 1/2 plus 1. 1/2. The vertex is negative 1 comma 1/2. I'm not sure what's going on, but. What's the pattern for a parabola like this? Tell you what, I'm gonna surprise you. Courtney, go for it.
Oh my gosh. What did you
What's the
say?
normal pattern for a parabola?
Up one, over one, up two.
Other way around, but
Oh, over one, up one.
over 1, up 1?
And then
over
over
two.
two, up four.
What about this one? Over 1,
Up a
up 1/2. That, by the way, is lucky because it'll actually get you to whole numbers. And then over 2, up what? John?
Over 2 up 2.
Over 2, up 2, correct, because it's half as tall as it used to be. We need to go from negative 2 to 3. So we already got to negative 2. I need to go all the way to 3. So Michael, take over. Over 3, up what? 4.5, correct. So over 3, up 4.5. So this is a half already. So up 1, half, and then up another 4. So you should be at a height of 5. These heights are actually pretty nice. This is 1/2. This is 1, etc., etc. And then last one, 1, 2, 3. So I have to go 1, 2, 3, 4. Over 4, up what? Pete?
Over 4 up 8.
8, correct, because it's normally 16. So over 4, up 8. Now keep in mind, you're at a half. You're going to go up to 8.5. 6, 7, 8. Here. So here's the parabola. It'll go from here. And here's the piece we're worried about. If I'm going to do an upper sum, here are the slices I'm playing with. There are 5 of them. 1, 2, 3, 4, 5. Take the upper from each, yeah.
Why is it 8 or 8.5?
Because you start at 1/2, over 4, up 8.
Oh, okay.
That's the annoying part of having a vertex and not a whole number. If you note, I'll draw in the upper sums. You notice the upper sum it kind of switches direction. Here you need the left one as the upper, here you need the right one as the upper. I think that might have been confusing in the calculator. I'll have to fix that. So, somebody give me the area. 1. So the upper sum is 1 times 1 plus 1 times what? What's the next one? Keep going. Oh, give me the next one.
It's 1/2.
That would be a lower sum.
Oh, no, it's up 1. Yeah, okay, never mind, it is 1 again.
It is another 1. Max, take over. What's the third slice area? The base is 1. We chose that deliberately. What's the height?
3.
Here's 3.
Oh, I was, okay, 5.
Second?
5.
That's the next one. 2. Do the next one after that. 1 times 5 and the last one? 8.5. Question?
Wouldn't it be 2.5, because we're starting at.
Let me look. Oh, wait a minute. Oh, do you go over 2 up to? Thank you for saving my bacon. You're right. That's 2.5. Yeah, squeeze in a 0.5 there. Thank you very much. I think that's the only one that wasn't goofy. Add them up. Should have 1 plus 1 plus 2.5 plus 5 plus 8.5. I'm gonna add the decimals together. 8, 10, 11, something around 16, 17, 18. What did I say? Or, well, rather, what did my calculator say? Let me just run this now. Go from -2 to 3, slices of 5. Is this saying 7? Oh, that I typed
I
in.
got 1.5 instead of 2.5
Where?
in the one part.
In this,
So it
it's
goes
over
from
2,
1.
up 2.
Oh, yeah,
Does that make sense?
that makes sense.
Okay, so let me try this again one more time.
But
Run
that's,
the
that's when
program.
I plugged it in the calculator, and when I plugged in y, I did like the y1 and multiplied it by 1, and you got
Mhm.
1.5 for some reason.
Oh, you did y1 times 1, or y1 parentheses 1?
Yeah, I'm pretty sure.
Okay, you have x squared over 2. I'm gonna type this in real fast. Sorry, I wasn't expecting this to go la la like that. I'm sorry, what?
Will be 5.5 or
Plus.
5?
Let me check. This would be over 3, up 4.5.
1.5.
Yeah, so I'm at a half already, so 1 and then up to 5.
Okay.
So that should be set. Plus x plus 1. Strat. From -2 to 3, slices 5. This is saying 18, so that's correct.
Huh.
That's very interesting. So I think these are right. Now there's something a little weird. Let's try the lower sums. You can almost do the same graph. Lower sum, lower sum, lower sum, lower sum, lower sum. Does that make sense visually? Michael, take over. Give me the areas, all 5 of them. Lower sum. That's the x value of
Base times
this.
height, right?
What's that?
Base times.
What's the base of this first slice?
1.
1. What's the height?
1.
This is 1.
What, so half?
It's a half. You take the lower of the 2. Does that make sense? 1 times a half. Give me the next one.
That one's 1, so it's 1 times 1.
That would be an upper sum again.
Okay. so
Here are the
it's
2
a half.
dots. It's another half. Plus, now try this one.
A half.
This is the half. What?
So is it 1?
Here are the 2 choices, 1 or 2.5.
So 1.
1. Keep going. What's the next one? I should have marked this.
1 and 2.5.
Yeah, 1 times 2.5. And then the other one, either 5 or 8.5. 5. I'll do the 1/2 as 0.5 just to be consistent. So I should get 5, 7.5, 8.5, 9, 9.5. Does that make sense? this is giving me 9.5. That's really creepy. Okay. I'm not sure what was wrong before, but trapezoid sum. Take the average of these two. Average of 18 and 9.5, 13.75. Midpoint sum, 13.125. And Simpson's rule, 13 1/3. That's really curious. Yeah, question.
I was just a couple decimal places off for the midpoints. I had 13.375.
13.375.
I could have totally done something wrong. I'm not sure.
I'll join the club. I can show you real fast. Here's the midpoint, 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 midpoint. So remember how, by the way, yesterday I showed people, I think I showed, no. There's a quick, you know how you get the heights, the weird heights? Tell me how. Jack, Pete, incessant talking. I don't think that's the first time you've heard in your life, yeah. Tell me, how do you find the heights of these midpoint thingies?
Plug it in the Y1 function.
Plug it in the Y1. Make sure the function is in Y1. And then do variables, Y variables, function, Y1. Parentheses. Now, question came up. Y1 parentheses, if you plug in any value of X, it'll give you the height, including these weird middle things like -1.5. But is there a way to get them all at once? Grab your calculators. Everybody. I want you to try this. Find the curly bracket. It should be right above the left parentheses. You have to hit, I think you have to hit second in order to get to it. Either second, yeah, second. Everybody find it? This is the indicator of a list. You can plug in a list of numbers like this. The very first midpoint is -1.5. Ever see why? Because the two endpoints are -2 and -1, and midpoint is -1.5. Then put a comma. That's an actual key. It's right above the 7. Then -0.5, or just -0.5. Another comma. 0.5, comma. 1.5, comma. 2.5. Close the curly brackets, which is second right parentheses, and then do a right parentheses. Again, these curly brackets indicate a list, as long as you use commas in between them. Go ahead and hit enter and see what happens. I gotta catch up with you on -1.5, comma, -0.5, comma, 0.5, comma, 1.5, comma, 2.5. Close curly brackets, otherwise it'll give you an error. Now, do you notice on the end of the screen it goes ... Hit the right arrow a couple of times. It'll scroll over to all the rest of the numbers. It gives you all the answers at once. You should have gotten 0.65, 0.65, 1.65, 3.65, and 6.65. Those are the heights of the mid. What you have to do is 1 times the first, plus 1 times the second, plus 1 times the third. So pretty much you just need to add all those up. And just because I give it to one person, I gotta give it to everybody. Is there a calculator way to add up all of these things in a list? Yes, if you're fast. Do you still have the list, the answer list on your screen? You can scroll back to the left to see the blah, 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 blah. This is a very obscure place to, I don't know if you'd want to do this on a test. If you're welcome to. I want you to look for the list menu. Can anybody find it?
Stat.
It's on the stat key, but you have to hit the second function first. Stat is right below delete. So look on the list key, and then scoot over to math. Excuse me. Every time I uncap a new marker, I sneeze once. It's just creepy. Look for choice 5. Sum. Select it. Now don't hit anything yet. It should have sum with a blink, blink, blink. what you need to do, it's looking for a list. This function for sum will only add up lists. It won't add up a string of number plus number plus number. Fortunately, there's a list on your screen. Here's what you do. Can anybody find this for me? We've done it before. ANS? That's your previous answer. Go ahead and type it in. How do you find that?
Second, negative.
Second negative. Go ahead and try it. What do you get?
13.1.
13.125? That's it. That's your midpoint sum.
Figure.
Question?
No.
Alrighty. I don't know what they're doing here. Oh, I know what they were doing, the worksheet. That's what was baffling. The program was right, the worksheet was wrong. The worksheet was doing a left sum, it wasn't doing an upper sum. Little weasel. It was just doing all the left-hand sides, no matter whether it was high or low. Which is a legit way to do it, but not the one we're doing. It's called the left sum, like the left-hand sum. And then a right sum, it was doing the right sum. All right. Okay, now that I know the computer is doing it correctly, everybody got the answer for number 3? Gentlemen, did you hear what I said? Yeah, close. Did everybody get the answers to number 3? Okay. Let me call this back. Now, let me give you the answers to 4 now that I'm confident the calculator is doing it correctly. So x squared over 2, minus x plus 2, from -1 to 4, and it is 5 slices. Here we go. The upper sum is 17. The lower sum is 10.5. The trapezoid sum is 13.75. The midpoint sum is 13.125. And Simpson's rule is 13.3 repeating, or 1/3. 13 1/3. Everybody good so far? All right, last one. Type in, this is gonna be kind of interesting. We didn't get all the way through this, did we? We started it. Oh, so 3 over x is gonna be from 1 to 5. There are 4 slices this time. Upper sum, 6.25. Lower sum.
Wait, can you, sorry, you say upper sum one more time.
Upper sum is 6.25. Lower sum, 3.85. Trapezoid sum, 5.05. Midpoint sum, it's disgusting. I rounded it to 4 decimal places. 4.7238.
Do you have it as a fraction?
I might be able to, after I'm done. Let me look. And then Simpson's rule is another icky decimal. 4.8325. 4.8325.
I don't need that. I just checked my fraction and it's still.
Okay. Good. And then the exact, 4.8283. 4.8283. There is no fraction for that because it's irrational. It's actually a logarithm.
How could you tell if it's a logarithm?
Oh, the only way I could tell it's a logarithm, other than cheating and looking at the answer key, is they're trying to do this. That's the original. I just pulled the 3 out in front, and that's the natural log. So it's 3 times the natural log of, the 2 boundaries, ln of 5 minus ln of 1, and poof. Yeah. And it repeats. Questions? In with those mysterious. Yeah. Number 5. We did some of it yesterday. Which one did you want?
Wait, on this, you're talking about this one?
Like there's upper sum, lower sum. I think we did the upper and lower sum yesterday, didn't we?
You just do the mid sum?
Midpoint sum?
Yeah.
Sure. Now there are 4 slices, So there are only 4 midpoints. Actually, while you're looking at the worksheet, can you tell me the values of x? That would be the midpoint values. What values of x should I plug in?
I don't know if I got mine right.
Oh, tell me. No death penalty if you're wrong.
Well, I have like 6 altogether.
There shouldn't be 6. There should be 4. Okay. There are 4 slices. They're only going from 1 to 5. So from 1 to 2, from 2 to 3, from 3 to 4, and from 4 to 5. So in your upper lower trapezoid, there should be 4 slices, and Simpson's rule, there should be 4 slices. This one, the midpoint should be 1.5, 2.5, 3.5, 4.5. Okay. So plug those in. What I would do is put 3 over x into the y equals screen, if you haven't already. See if we got it. It's there, good. And then, if you want to just plug them in individually, you're welcome to. Variables, y variables, function y1. If you want to try the list, enter them all at once, you're welcome to. Or if you want to just do them one at a time. For example, 1.5 should give you a height of 2. So the midpoint sum should be 1 times 2 plus, and then let's try 2.5. It's 1.2, 1 times 1.2, plus 1 times, let's try 3.5, yuck, 0.8571, blah, 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 blah. What that really is 6 over 7. This is basically 3 over 1.5, 3 over 2.5, 3 over 3.5, and 3 over 4.5. Interestingly enough, it might even be easier without a calculator. Multiply the top and bottom by 2 and get rid of the decimal. So this would be 6 over 3. This would be 6 over 5, 6 over 7, 6 over 9. Add those up and you'll get your midpoint sum. So 6 over 3 is just 2, plus 6 over 5, plus 6 over 7, plus 6 over 9. And, oh yeah, I do have a fraction. Jen, if you want it, you probably don't need it anymore. 496 over 105.
Thanks.
Okay, no problem. Which is approximately 4.723. There's your midpoint. Does that make sense?
You got the 1.5 from the lower and upper zones?
Right, well,
And then
did you see the slices, where the slices are? What's the very first slice, from what to what? In number 5. They want all the slices to have a width of 1. So where's the first slice? From what value of x to what value of x?
1.5.
You're working too hard. The first slice, period. If you just slice, 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 so that each slice is 1 inch.
Oh, 1 to 2.
1 to 2. What's the midpoint of that?
1.5.
That's where the 1.5 comes from.
Okay.
It's halfway between the ends. So you take halfway between the ends for the first one, that's 1.5. Halfway between 2 and 3, that's 2.5. Halfway between, etc. And the function is 3 over x. So it's 3 over the midpoint, 3 over the new midpoint, 3 over new midpoint, 3 over new midpoint. And then just find the height, 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 height.
Okay.
Okay. Any other ones? Once you have the midpoint nailed down and the trapezoid, you can find Simpson's rule. Any other questions? Alrighty, check out your notes, please. I have one last topic for the chapter. The chapter is nearing its end, which means there is a chapter test coming up fairly soon. I'm predicting next Friday. Anybody else? I need to check the homework. All right. It is a weird little theorem, in my humble opinion. And it was hinted at about a month ago, 3 weeks ago, a month ago. quick review. The first fundamental theorem of calculus. The reason I'm bringing this back up is because you will need to know the first fundamental theorem of calculus on the test. The first fundamental theorem of calculus says if f of x is continuous, that basically means if the integral exists. On the interval. If f of x is continuous on the interval from a to b, and those can be any numbers you want. And again, let me just highlight, why am I saying it has to be continuous? That means no vertical asymptotes, no holes, no definition breaks. Because if you have a hole or a vertical asymptote or definition break, trying to get the area under the curve is impossible. It'll destroy itself as soon as you hit the discontinuity. On an asymptote, if you have the thing going up to infinity, it'll make your integral infinite. It won't be able to calculate it. And you'll be dividing by 0 halfway through it and blowing it up. If there's a hole, you're also dividing by 0. If there's a definition break, you can't do it from one end to the other. It just doesn't know how. So any discontinuity will destroy this. It'll invalidate it. So if f of x is a well-behaved function from one side to another, it can explode anytime after that, I don't care. But as long as it's well-behaved on the interval we want, then the integral from a to b, what's called a definite integral, because you actually have definite numbers, of f of x dx is equal to capital F of b minus capital F of a, where capital F of x is the antiderivative of regular f of x. We've used this before, many times. To find an actual answer, like an area under a curve, an exact answer, and we did that on the worksheet today too, you just run the antiderivative from a to b. Plug in the end of the interval, and then subtract the plug-in for the beginning of the interval. Quick review and question here. Example, calculate this for me. Just a nice quick one. Tell me how to do it. Who's feeling brave? Jack, help me out.
Wait.
How do you take the
So
antiderivative?
it's like antiderivative of, you plug in 6 for x or something, I don't know.
Where? B. What's the antiderivative of x squared?
1/3 x cubed.
Right. Normally there's a plus c. I'm going to leave it off. I'll ask people why later, because normally I never leave it off. And I'm just going to do this. This is code for the antiderivative from 3 to 6. How do you calculate it, Michael?
So you have to plug both numbers in twice.
Yeah, which one first?
The b.
Yes, which is what? In this- 6. You plug in 6 first. By the way, you don't have to, but that's a constant you can pull out in front, which will make your math easier. 1/3 times the antiderivative of x cubed. Well, plugging in from 3 to 6. So tell me what that looks like. I just got the 1/3 out of the way. What would you plug in first? Go ahead, Michael. You just said
Oh, 6.
6. So do it.
So is it 6 to the 3rd?
Yep. And then do what? You just did this. set jog memories. That's all you do. Now simplify it, but that's all you do. Let's do this. What's 6 to the third power, Eminem? 216 minus 27. Somebody do that for me. 189? What's a third of 189? 63. What am I doing? That's your answer. That's the area under the curve of x squared if you run it from x equals 3 to x equals 6. There's 63 like square inches underneath the curve. Does that make sense? That's called a definite integral, and that's how you run these. Again, don't do a brain dump of how to do antiderivatives. We've done antiderivatives of lots of things this chapter and last chapter. We know how to do polynomials. We know how to do sum trig functions. We know how to take the antiderivative of 1 over x. That's ln of x. We've done, that's about it. We've done integration by parts. We've done substitution. We've done a lot of different integration. The whole purpose of teaching all of that to you so that you can do these. Make sense? Do not rely on the calculator for 2 reasons. Number 1, it doesn't do anything to your brain except turn it into a vegetable. I can get a chimpanzee to punch buttons on a calculator. I need a thinking person to know how. And second, if the answer has radicals or other irrational numbers in it, the calculator is helpless to get an exact answer. And if I'm demanding an exact answer on the test, and you give me a decimal approximation, I will take off at least half. So beware. I need the exact answer. Sometimes I'll say, just give me a decimal approximation, because it's horrible. Other times, I say, this isn't horrible at all. I want the exact answer. Well, even that calculator would get 6 and 3, but on this one. But if the final answer were like 5 times the square root of 7, good luck for the calculator giving it to you. It will not. It'll give you a decimal, and you will lose half your points. I want you to write 5 radical 7 as the final answer. Does that make sense? All right. The fact that there is a first fundamental theorem of calculus implies something. It implies that there is a second fundamental theorem of calculus. Write this down. I'm abbreviating. The second fundamental theorem of calculus says this. If f of x is continuous, actually do me a favor, I want to change the variable. If f of t is continuous. We've done that for physics. We didn't call it f, we called it s or v or whatever. But we've done formulas with t as an input before. If f of t is continuous, and if g of x exists on a particular interval, in other words, if it doesn't have poles, vertical asymptotes, definition breaks, if it exists everywhere, it doesn't blow up, then this is a very weird looking problem, but it's actually one of the easiest theorems to work. Then, actually I'm gonna, let me add one more word, and if capital F of t is the antiderivative of f of regular f of t. Now, we kind of know that already. When we use a capital letter in calculus for a function, we usually mean an antiderivative. It's very rare we don't. Then, capital F prime of t. Let me see. Hang on a second. Is equal to integral from c being any constant. Should have mentioned that up here, sorry. To g of x of f of t dt is equal to, oh, excuse me, f of g of x. That may look very confusing. This is one of those things where doing it is a lot easier than explaining it. Let me just run a problem for you. The problems are almost laughably easy. Suppose, quick example. Suppose that f of t, what the heck, f of t, is equal to t squared. Let's make it nice and easy. And the antiderivative of f of t, oh, whoops, oh, where you left t dt, is equal to capital F of t plus c. The plus c is usually in it. First of all, any surprises so far? I haven't even told you what the antiderivative is. But what if they did this? I want to take the, let me remember what this is called. I saw it about 3 chapters ago. It was one of the other pieces of notation. It's actually something with which you're very familiar. It's another way to write what? Derivative. Derivative using what variable?
Using x.
So this of the integral of from c bit, let's just pick a number, from 5 to x squared. This is a very complicated looking problem. First of all, there are 2 different variables going on here. This function, I mean, this is using t, this is using x, and for the first time ever, I'm giving you a non-number to plug in. Now you can plug in anything you want, but here's a quick question for you. I'm going to start at the very dirt level beginning. What happens when you take the derivative of an antiderivative? Just off the top of your head.
Just goes back to
They cancel. It goes back to
what it was.
the original function, whatever it was, right? So if you have an antiderivative and then take the derivative, it should go back to the original. Here's what this is going to be. It's kind of a bait and switch. I'm taking the derivative of an antiderivative, so at least theoretically these should cancel. The only difference is, this goes from t equals 5 to t equals x squared. Plug this in for t. So it's basically this. Do the first fundamental theorem. It's going to be capital F of x squared minus capital F of 5. Does that make sense? Now, actually there's one exception. What does the derivative do to an antiderivative? Oh, I see what I grouped up. It's supposed to be a little out. Sorry, my fault. What does the derivative do to an antiderivative, Michael? They cancel. Look up here. The reason I erased the capital is because I would have taken the antiderivative, but it already canceled. It wasn't able to. It just stays the same. So it goes back to the original. But you do have to plug these in. F of x squared, go ahead and plug it in. Don't tell me. Max, plug in x squared into the original function.
So you just get x squared,
X squared squared, correct. And then time minus, and then plug in a 5.
25.
25. And then plus c. Math people. What's C minus 25? C. This is actually the fourth plus C. So basically all this does, whatever this top thing is, you plug it into the original function and you're done. All this blah 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 was to prove it. Now this is a fun topic, but I'm not 100% sure we need to cover it this chapter, especially since we're so short on time. Tell you what, I have the worksheet for you, but all I want you to do is, this is actually gonna be a very short, 1 through 6. Oh yeah, sorry. So 1 through 6 for tomorrow, skip 7 and 8 unless you wanna try and earn some credit. Just 1 through 6. I'm gonna just leave that off the chapter test for now. I'm gonna put it on the next chapter test.
What about the application for some of these problems?
The second, the fundamental theorem? I actually don't know off the top of my head. I do know that there's change of variable problems, and this is handy for that. That's a really lame explanation, but yeah. All right, please stand. We're out of time. Just fair warning, look up here, please. Eyeballs at me. Tomorrow, we are going through these things. It's going to be brief. This should be a review. Hold on, 8th grade, I'm coming. Give me a minute. And I'm planning on a practice test tomorrow because I want to go. The Monday and Tuesday is no school next week. I'd like Wednesday and Thursday to go over the practice test. And maybe Thursday, I can run off another practice test, we work on in groups, if you have extra time. And then Friday will be the actual test.
Can we have an answer key for the weekend?
Please God, yes, I will try my best. Let's pray. In the name of the Father, and the Son, and of the Holy Spirit. Amen. Glory be to the Father, and the Son, and of the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Bye,
Right?
guys.
Bye-bye, y'all.